Hey everybody, we are continuing on limits. The main topic will be infinite limits, but we also are going to cover something called finding limits from a table. So we're just going to start from an example. I'm going to give you an example, and then you are going to try one on your own. So we're going to take the limit as x approaches 1 of square root of x minus 1 over x minus 1. Now, I know you know how to evaluate this using conjugates. So that's the technique used before. But what if you didn't have the conjugate rule? What is a way? This is going to be a technique to find a limit. It's not analytical, it's not definitive, but it gives you an idea of what's happening to the function. So that's why we're doing this. So obviously, when you plug in 1 on top, you get 0. 1 on the bottom, you get 0. And we learned that that's called indeterminate. We don't know what the limit's going to be. It might not exist, or it might be an actual value. And so what can we do? So you can kind of get an idea of what's happening by making a table. And so let's do this. This is going to require a calculator. And in the center will be 1. It's like a number line kind of, but it's a number line table. So we're going to pick numbers to the left and to the right, and I'll explain what's happening here. Hopefully I'm leaving myself enough room. So in a limit, if you remember, we want to approach 1 from both sides. And we want to see what's happening to the y values of the function as we get close to 1. And so we're going to just try to plug in some numbers and see if we can observe. Now, it's important that you kind of understand the numbers I plug in and why I'll plug in the numbers I choose to. So I'm going to start at 0.9 because 0.9 is kind of close to 1. So these will be the x values, and this will be the function f of x, which is our fraction there. So I want to get closer and closer to 1. Well, the next number I want to choose is 0.99 because that's getting closer to 1. Then 0.999, it's getting really close to 1. And then 0.9999, and I'm approaching from the left side. Now, if you pop this in your calculator, on the first one you get 0.5131. And then you pop the next one in your calculator. And by the way, there's a fast way to put these in your calculator. So if you ask me on Monday, I will show you how on your calculator you can quickly get these numbers punched into your function. So remind me, please, because I don't want to forget to do that. The next one is 0.50126. The next one is 0.50013. The next one's 0.5001. So from the left side, here's what we're going to do. We're going to evaluate this limit. And this, again, we're just guessing because we could be wrong. But plugging these numbers, we get an appearance of what it's going to get to. So I'm going to approach 1 from the left. Sorry for that ugliness I just wrote. Go ahead and pause, take a guess, and you can check if you're right. So to me, it looks like it's getting closer and closer to 0.5. So from the table, it gives us an idea of what it's approaching. And then from the right, we're going to do the same thing. We're going to start at 1.1 because that's to the right of 1. But even closer is 1.01, even closer 0.001, and closer 0.001. Now again, you plug into your calculator, and this will get 0.4881. Plug the next one, you get 0.4988. You plug in the next one, 0.4999, and you plug in the next one, 0.4999. So as we approach 1 from the right, okay, where x is getting closer and closer to 1 from the right, what does it seem like? So we're going to approach 1 from the right of our function that we had. So go ahead and pause and see what you think, and then unpause and see if you agree with me. So for me, we're getting really close to 0.5. So my conclusion, we learned if the limit from the left equals the limit from the right, then the limit is going to be what the left and right approach, and that's going to be 0.5. So this is called finding a limit from a table. So this helps you hopefully conceptually to see what limits are. And I won't give you a lot of these to do, they're kind of tedious, but I want you to understand the concept of what's happening. So I'm going to give you one, and you are going to try. Oh, and by the way, to do this using conjugates or factoring, let me show you and verify that our answer was correct. So this is a review of what you did last night. So we're going to multiply by 1. My 1 is going to be the conjugate, radical x plus 1, over radical x plus 1. And then we want to distribute that. So if I distribute the purple, let me do this. We're going to get radical x times radical x is x. Radical x times 1 is radical x. Then, oh, I should have matched the color. Let me go back and match the color, Yoshida. X plus radical x. And then I will use green. We'll distribute that. That'll get us minus radical x minus 1. And on the bottom, again, you don't want to multiply the bottom out. We multiply by the top out because we knew it's going to rationalize and get rid of the radicals. But our end goal is to get something to cancel. We want factored form, and then we can cancel. So you will notice that these will cancel because we have difference of two squares. So I'll go ahead and rewrite this for you. We have the limit as x approaches 1 of x minus 1 over x minus 1 radical x plus 1. And you will notice those cancel. To take the limit using the shortcut, we have polynomials and such. We can just plug it in. We get radical 1 plus 1, which is 1/2, which is 0.5, and that's what we found over here. So that's just to verify. So the second way was analytical. The first way was graphical, and it didn't prove it's 0.5. It just suggested that the limit is 0.5. All right, you are going to try this one. The limit as x approaches 2. And I want you to do this graphically. All right, go ahead and pause this video, and then we will come back and see what I got. All right, so all of you should have made a table. See, in math class, we incorporate other classes. Woodshop, we're making tables. Ha ha ha. Yoshida is very funny. You should be laughing very loudly. Ha ha ha. Okay, so the logical thing is 1.9, 1.99, 1.999, and 1.9999. Whoops. And then 2.1, 2.01, 2.001, 2.0001. Now, let's plug in. You should get 2.8525. Then you should get 2.9850. Then you should get 2.9985. And then 2.99985. So let's look at the trend here. Looks like we're getting really close to 3. Hopefully you agree. Then from the right side approaching 2, I get 3.1525, 3.0150, and then 3.0015, and then 3.00015. Now, approaching 2 from the right here, clearly these numbers are getting closer to 3. So your conclusion should have been that it appears, we haven't proved it because we're just doing a table, it's not analytically. It appears this is 3. All right, how would you have done this analytically instead of with a table? This would require you to know how to find the difference of 2 cubes. And I don't know how many of you remember that, but if we factor the top, we would get x minus 2, and then x squared plus 2x, I think I'm doing this right, plus 2. So there's a magic formula for that. And if it was a plus instead of a minus, we would end up with a minus here. So basically it's x cubed and 2 cubed. So it's the first minus the second, and then the first squared, one of each, the 2 and the x, and just the 2. And if it's a minus here, there's a minus there, the rest are plus. If there's a plus here, that would be a plus, a minus here, and and a plus here. There'd be one minus in location. So hopefully I did that right. I'm doing it from memory. And our whole goal was to factor and cancel. Bam, now we no longer have a 0 in the denominator because this was indeterminate. And now we plug in 2 squared using the shortcut. It's actually a theorem, the polynomial, the limit of a polynomial. And on top we get 4 plus 4 plus 2 over 4. Uh-oh, did I mess up somewhere? I'm so sad. It's supposed to come out to be 3, right? Let me see where my factoring went wrong or what I did wrong. So 4, x minus 2, x minus 2, x squared plus 2x plus 2. All right, I need to check. I think maybe I did not factor this correctly since I was going from memory. Let me see what happened here. I'm not seeing. So go ahead and pause. I can't pause. Or you can fast forward as I double check. I'm going to look for the difference of two cubes. I think I used the wrong formula. Sorry. Difference of two cubes. All right. Huh. It looks like I did it right. Oh, I know my problem. Yoshida. This is 2 squared. Okay. That's 2 squared. So what I did wrong, so we get x minus 2 because it's x cubed minus 2 cubed. So you get the first one squared, one of each, and the last one squared. I forgot the last one squared. So that will give us 4 here. That will give us 12. That will give us 3. Sorry. So that's how you would do it analytically. So we have done 2 examples. So that is a review of last night's on top of adding how to use a table. All right, now here is our new topic, and this is going to be infinite limits. And let's do this. Whoa. Trying to think. We'll do a one-sided limit to start with. The limit as x approaches 1 from the right of 1 over x. So how are we going to do this? We're going to do with the table and see what the table does. And then we're going to look at the graph and then make some connections. And there's actually going to be a definition for us. So we'll talk about this. Again, you'll need your calculator. So I create un table. We're approaching 1 from the right, so I'll put 1 there. And this will be our x values. This is our function. So we'll start at 1.1, 1.01, 1.001, 1.0001, 1.00001. And so if you have a calculator, go ahead and, yeah, I'll figure these out for you. Let me bust out my calculator. So the first one is going to be 0.909091. Oh, I am so sad. I am so sad. I don't want to start this video over, so my apologies. I meant to approach 0. Sorry. The only thing that's going to change to approach 0, I'm going to start at 0.1, then 0.01, then 0.001, then 0.000. Yeah, okay. And that's going to change. My apologies. I'm sorry. Okay. In your calculator, do 1 divided by 0.1. You will get 10. Go ahead and try it. Convince yourself. Then 1 divided by 0.01, you will get 100. 1 divided by 0.0001, you will get 1,000. 1 divided, yeah, you get the picture, right? 10,000, and then 100,000. What's happening as I get closer to 1? So you should be seeing it. It just keeps getting bigger. It doesn't approach a value. So here's the first concept. When you're taking a limit and the top number is a constant and the bottom number approaches 0, it's going to get bigger and bigger and bigger, unbounded. So technically, it's not going to have a limit because there is no number it's getting close to. It just gets bigger and bigger and bigger and bigger. So yeah, try to convince yourself of that. You need to understand when you divide by a number that's getting close to 0 and there's a constant on top, it's going to be unbounded. So they, by definition, okay, because technically it does not have a limit, does not exist, but this book defines whenever your limit goes really big, really big, we say that this limit equals infinity. Now, infinity is not a number, so it's not actually approaching infinity, but basically it's telling you that it just keeps getting bigger and bigger and bigger unboundedly. Okay, so mentally, see if you can draw the graph. What does that graph look like? So I'm going to draw an X and Y axis. Do I have line tools? I don't know. Here's X, here's Y. You're approaching 0 from the right. What is the graph going to look like? I will show you, but you kind of think about what you think, and then I'll explain what this is saying. So you can pause and then just come back. Bam, that's what it's saying. So it's important that this mental picture makes sense to you. So what is this saying? As I approach 0 from the right. So what's happening? I am approaching 0 from the right. I'm approaching this way. And then what does the limit tell me? It tells me what the y value does. Well, this should tell you the y value keeps getting bigger and bigger and bigger. So as I approach 0 from the right and approach 0, the y value just keeps getting bigger and bigger and bigger. And so basically we have a vertical asymptote at 0 because I can never reach 0. If I were to divide by 0, this would be undefined. The function would not exist. So the function does not exist on the y-axis, so the line never touches it. But this graph gets bigger and bigger and bigger, so therefore we have a vertical asymptote there. Okay? Now I want you guys to try this. Not that. I want black. The limit as x approaches 0 from the left of 1 over x. So try to make a table. See what happens. Go ahead and pause. And then come back. Okay, so you're back. I am approaching 0 from the left, so I put the 0 here. Therefore, I can approach towards 0 from the left. So we're trying to build in your brain the concept. Now, what's really close to 0? Negative 0.1. What's even closer? Negative 0.01, negative 0.0001, negative 0.00001, negative 0.000001. Now, in your calculator, go ahead and start punching in numbers. You should see you get negative 10, negative 100, negative 1,000, negative 10,000, negative 100,000. So, technically, it doesn't have a limit. It's not approaching a number. It just keeps getting bigger and bigger and bigger, but in a negative way. So, by definition, when a limit is unbounded, we say it goes to infinity, but since it's negative infinity. So these are infinite limits. And again, important, when do you get infinite limits? Infinite limits occur when the top is a constant and the bottom goes to 0. And it could be a positive infinite limit or it could be a negative. So back to this graph, see if you can draw what the graph looks like on the left side. So see if you can do that. Go ahead and pause and then come back and I will show you. All right, so here we go. And we will learn why I do what happens as I go to the left. That's going to be limits at infinity. It's a future lesson. But for here, as I approach 0, whoa, that shouldn't have done a line. As I approach 0, I'll draw an arrow, so I'll show you what I'm doing. As I approach 0 from the left, that's what we're doing, we know the graph gets really big negative. So as I approach this way, it gets really, whoa, I don't know why I did that. Let's try that over again. It gets really big negative. So it cannot equal 0 because dividing by 0 doesn't exist. So as I get close to 0, it gets really big negative. This is an asymptote. So what should you know from this? You should realize that when we have an infinite limit, we have a vertical asymptote, and you should know why it moves downwards, because it's negative infinity. And here, it's positive infinity, so as I approach from the right, it moves upwards. So you should be able to draw the graph. If I tell you the limit's infinity, you should know kind of what it looks like. Now here is the last question. See if you remember this. So what would be the limit as x approaches 0 of 1 over x? So this is your last problem. Go ahead and pause. Think about this. All right, so here's the answer. It does not exist. Why? Why does it not exist? Because we learned a couple lessons ago that if the limit from the right and the limit from the left are different, they are, this is negative infinity, that's infinity, then the limit does not exist. Now, if they both came out to infinity, then this would be infinity. If they both came out to be negative infinity, this would be negative infinity. But since the left and right are not the same, the limit does not exist. So that is infinite limits. What we'll do is give you some more examples. You're going to try some of these. I probably should give you... Now, I explained the definition. I think you got it. But we probably should talk about asymptotes. Do they talk about it yet? Let me double check here. No, they don't talk about it, so I won't talk about it yet. All right. So let's do this. We'll find, I'll give you a problem to try. And we'll talk about the answer. So let's do this. The limit as x approaches 1 of x over x squared minus 1 squared. So let's do this, and then, so you could do a table. Actually, I'll do this for you. And then the next one I'll have you do. So here is the main idea. If the top approaches a constant and the bottom approaches 0, then you will have infinity for the limit. And you should know graphically what that's going to look like. So let's go ahead and do this. Actually, let's go from the left, okay? And see what's going to happen. So the top is going to approach 1. So I'm going to write it as approach 1, right? The bottom, if you plug in a number very close to 1, 1 squared minus 1 is approaching 0. The bottom approaches 0. But here's what's important. Is it a positive number as it approaches 0, or is it negative? And I'll explain. Say you put in 0.9. 0.9 squared is 0.81. 0.81 minus 1 is a negative number. But since you're squaring it, it's going to be positive. So I'm going to put a positive 0. Since the top is positive and the bottom's positive, the answer is going to be positive infinity. If that didn't make sense to you, go ahead and process through that again. All right, and I'll do another one where you're not, okay, yeah, here, you do this one. You do this. And then we will talk. So try that one. All right, so hopefully you paused and you came back. So if you plug in 1 on top you're going to get 1. It's going to approach 1. The bottom, oh, I forgot the right. Okay, do it again. Sorry. I forgot that. I messed you guys up. So from the right this time, what do you get? I'm assuming you paused again. So now we come back. The top is approaching 1. The bottom's approaching 0 again. So again, we have it approaches 1. I probably should have approaches 1. The bottom approaches 0. But does it approach 0 from positive numbers or negative numbers? So you put 1.1 here and you square it, and what do you get? 1.01 or 1.01. You subtract 1 and you square it, and since you're squaring it, it's positive. So it's going to be positive on the bottom, and you're going to get infinity again. So the graph of this, let's not graph it yet. We'll do something else. So again, you need to make the connection between what the limit says and what the graph looks like. So let's do this. The limit as x approaches 1 from the left, no, liar, liar, pants on fire. As x approaches negative 1 from the left of x over x squared minus 1 squared. I'll give you 2 to do. And do this one. So go ahead and pause and do these 2 and then come back. All right, on this, I'm going to use this arrow for approaches. The top approaches negative 1, and the bottom's going to approach 0, but it's going to be positive again because we're squaring it. So the top's negative, the bottom's positive. This will be negative infinity. Here, the top will again approach negative 1. The bottom's going to approach 0 again because 1 squared minus 1 is 0. But since it's squared, it's approaching positive 0. So that's going to be negative infinity. So hopefully you guys got that. So what is this graph going to look like? So try to draw to the best of your ability what this graph's going to look like. You're actually not quite ready because you don't know about the horizontal asymptote situation. All right, let me plug in some values. That's 1, that's -1. Let me draw a dashed line. I wonder if I can do this. Well, let me make it dashed. Can I do it? No, I can't. Let me get rid of that. I'll do a dashed line. So why am I doing a dashed line? You should know if you have limits of infinity or infinite limits, it becomes an asymptote. So hopefully you graphed it. At 1 from the left and right, it goes to infinity. So hopefully you did that. You may have been confused what happens to the right, so I don't mind if you didn't know it did that. And again, it goes up there and down there. So maybe something like that. And then it goes down there. So again, you may not know what's happening here or here, but you should know this and this. Hopefully you got that graph. Hopefully it made some sense. Now we're going to talk about, and we have a definition. So this is something that you'll be quizzed on. This is something you have to memorize. This is something you have to know. So definition of vertical asymptotes. I wonder if I could type this in. Yes. Can I get the bigger keyboard? Oh no. Beautiful. Definition of vertical asymptotes. So I will give you the definition right below that. Let me go to my pen. If the limit as x approaches a of f of x equals plus or minus infinity, or the limit as x approaches a from the right of f of x equals plus or minus infinity, or the limit as x approaches a from the left of f of x equals plus or minus infinity, then the line x equals a is called a vertical asymptote. Whoopsie daisies. So this should be intuitive from the previous example we did. You shouldn't have to memorize this. It shouldn't be something where it's confusing and how are you going to memorize this A, this plus, this minus. You shouldn't have to. This should make sense if you understand limits, you understand the infinity and the process we went through. So you will have a quiz in the future on definitions, and this is one of the definitions of vertical asymptote. There are AP test questions where we'll have this, and you will have to conclude like choice A, there's a vertical asymptote, x equals A. So Y3, in this first one, they both go the same direction. As I approach A from left and right, they either both go up or they both go down. Here, as I approach from the right, it's going to go up or down, one or the other. And here, as I approach from the left, it's going to go up or down. So whether they both go up or they both go down, or one goes up or one goes down, it's still a vertical asymptote. So that is the definition of the vertical asymptote. Just throwing that out at you. And let's do one more example, and we will graph, see if you can figure out what something looks like. All right, so I'm going to give you a function. Hang in here. I hope it hasn't been too long. I didn't time myself here, so I don't know what's going on as far as time restrictions. I hope it's not the over 1 hour like that last one. All right. What does this function look like if I were to graph it? So the first question are, where are the vertical asymptotes? Are there any vertical asymptotes? And so you should know vertical asymptotes occur when? When do you have infinite limits? Infinite limits occur when the top number approaches a constant and the bottom approaches 0. So here's my question. What values of x make the denominator equal to 0? You can pause it. I'll give you the answers in a second. Okay, hopefully you said 1 and 3. Now, first you have to make sure that nothing cancels. If something cancels, you have to cancel first. But at 1 and at 3, if you plug in 1 here, the top's a constant and the bottom's 0. If you plug in 3, the top's a constant and the bottom's 0. So therefore, you know there are vertical asymptotes at x equal 1 and x equals 3. So we're going to evaluate what this graph's going to look like. So this will be the last one, maybe? No, we're going to do more of these. I apologize. There's so much. This is a long section. Let me finish a couple more example problems. The good news is you don't have class tomorrow or today. It's actually, I'm giving you this today. Believe it or not, it's like 4:30 in the morning right now. And I'm doing this lesson right now. Craziness, huh? All right. So we know we're going to have a vertical asymptote at 1 and 3. So let me do that. And let me do that. Now, which way are they going to go? That's the question. So that's your job, is to find if the vertical asymptotes go up or down using limits. So you have to use limit notation. So go ahead and pause and see if you can figure that out, and then come back. All right, so let's do 1 first. We have to take the limit as x approaches 1 from the left of f of x. And we'll do the limit as x approaches 1 from the right of f of x. And see if you can work with me here. So I'm approaching 1 from the left. So if this is approaching 1, clearly the top is approaching -1. Right? And then on the bottom, work with me here. I'm approaching 1. As I approach 1 here, this gets really close to 0. But 0 squared, or a number close to 0 squared, that's going to be positive. So the bottom's going to be positive there. And I plug in 1 here. 1 minus 2, or 1 minus 3 is going to be -2. That's going to be negative. But we're still approaching 0 because this is approaching 0. So if you look, the top is negative, a plus and minus on the bottom would be negative, and a negative divided by negative is a positive. So that's going to be positive infinity. So you can go ahead and pause again and try this next one. Okay, so this next one, let me walk you through this. That's what happens at 4:30 in the morning, you can't talk. So I'm approaching 1 from the right. So it's a number bigger than 1. So like 1.01 minus 1 is going to be close to 0. It's positive, and I square it's positive. So that's going to approach 0 from a positive value. Oh, and the top approaches -1 again. And then if I plug in 1 here, 1 minus 3 is -2. It's going to be negative. So the same thing's going to happen. Negative on top, a positive and negative make negative, so two negatives make positive, but a constant over 0 goes to infinity. Whoa, Yoshida. I totally blew it. Two negatives make a positive. Why did I put a negative there? I hope I didn't mess you guys up. I'm sorry, I'm tired. It's early in the morning. Actually, late at night. I haven't gone to sleep yet. Okay. So that is what's happening at 1. So visually, let's graph this, and then you can work on the other ones. You don't know it does that, but I know that. And it's going to go up because it's going to positive infinity. I know it's going to go up there. Okay, but what's going to happen next, we'll see. All right, we have to check what's happening at 3. What is happening at 3? So you guys go, I'll go ahead and set this up, and you guys can pause and try it. The limit as x approaches 3 from the left of f of x. The limit as x approaches 3 from the right of f of x. Go ahead and try this, and then come back and I'll show you. All right, so we're approaching 3 from the left. So 3 minus 2, the top's going to approach 1. And then 3 minus 1 is 2. 2 squared is 4, so it's positive. And then 3 minus 3 approaches 0, so we know the bottom's approaching 0. But we're approaching from the left. To left of 3, it'd be like 2.9. What's 2.9 minus 3? That's negative. So on top is positive. A positive and a negative make a negative. So a constant divided by 0 is infinity, but the bottom's negative, so it's negative infinity. Now let's try the next one. 3 from the right, which is like 3.1. So the top is approaching 1. 3.1 minus 1 is 2. 2 squared is 4. That's definitely positive. This is definitely approaching 0, so it's 0. But 3.1 minus 3, numbers bigger to the right of 3 are bigger than 3. Bigger than 3 minus 3 is positive, so it's positive. They're all positive. We have a constant on top, 0 on the bottom. That's going infinity. So approaching from the left, it goes to negative infinity. Approaching from the right, it goes to positive infinity. And so these connect. You don't know where and how, but I'm just going to draw these, and that goes that way. But so that's it. Make sure you understand what happened here. Why it's positive infinity, why it's negative infinity, what's going on. It's important that you get these. All right, so that is that. I'm going to do one more example. And if you think you're tired of listening to me, I'm tired of doing this, and I'm tired sleepy because it's late. I want to get some sleep. I don't think it's going to happen tonight. All right. One more. We're going to find vertical asymptotes. This is going to be the last one for sure, for sure, for sure. Okay? For sure. The graph of f of x equals x squared minus 4x plus 3 over x squared minus 1. All right, so to have vertical asymptotes, the denominator needs to be 0 and the top can't be 0. So to make sure that doesn't happen, we need to factor the top. That's going to be x minus 3, x minus 1. The bottom is the difference of two squares, x minus 1, x plus 1. Now, if you're not fast at that, I will have a study session on factoring. You need to be able to do that. You shouldn't have to make your Xbox and do all that crazy stuff, okay? So these x minus 1's cancel. Now, you're not allowed to divide by 0, so you need to make the stipulation that x cannot equal 1. The function does not exist at 1. In other words, there's a hole at 1. Because when x is 1, you divide by 0, that doesn't exist. So the function does not exist at 1. So when I cancel this, I'll rewrite it again. But x cannot equal 1. It's undefined at 1. So we will do that. All right. Now, where is the vertical asymptote? Pause and think about it, and then I will tell you. All right. Vertical asymptote, where is it? There's a vertical asymptote where? At x equals -1. Hopefully you got that. Let me draw a graph. That's not so pretty, is it? Oh well. -1, +1, 2, 2, 1, 1. Now, you don't know this yet, but there is a horizontal asymptote at x equals 1. Some of you may know that. I'm just going to draw that out there. You don't have to know that yet, but I know that. And we have a vertical asymptote at -1, so I'm going to go ahead and draw that. Now go ahead and decide what the graph looks like. You can pause and then come back. All right, so we need the limit as x approaches -1 from the left of this function. Let's evaluate this. So if I put -1 on top, -1 minus 3, that's going to approach -4. And the bottom, I'm approaching -1 from the left. Okay, be careful. To the left of -1 would actually be -1.1, because this is -0.5, -0.6, -0.7, -0.8, -0.9. That's to the right of -1. So this is -2, -1.5, -1.4, -1.3, -1.2, -1.1. So to the left of -1 is actually -1.1-ish. -1.1 plus 1 is negative, so it's approaching 0 from negative numbers. So since the top and bottom are both negative, we're getting in positive infinity, so we know it goes up. And there's my asymptote, Alabama. And we have that situation, okay? Now, I have to do from the other side. So you take the limit as x approaches -1 from the right of the same function. Whoa. Okay, now just to note, this approaches and all this notation I do there, and there, and there, and there, and there, is for you. You wouldn't actually write that on a test. Please don't write that. That's just for you to kind of see my thinking in my head. That's what's going on in my head. So again, I plug -1 here. The top is approaching -4. The bottom's approaching -1. -1 plus 1 is 0, so the bottom is approaching 0. But the right of -1 is over here. That's like 0.9, 0.99. -0.99 plus 1 is positive, so that's positive. It's approaching 0 from positive numbers. A negative and positive is negative, so it's negative infinity. That means it's going downward. There's my other asymptote. That's a rough graph. So that's what it looks like. So hopefully that wasn't too long, but you have the whole day to look this over, and you have the weekend to look it over. So make sure this is making sense. Please don't memorize these. It should be making sense. It should click. If not, you should come visit me during office hours, which I'll have next week. So have a great weekend. I'll talk to you guys later.